All right, so today we're doing section 412. So it's the introduction to higher degree polynomial functions. So we've been doing polynomial functions already. We've done linear functions, which you can see number one. That's like the y equals to mx plus b type of look. Okay, so lines. We've graphed lines already. We've graphed quadratics already. That's the x squared power, right? So anytime you see an x squared, you're looking at a parabolic function, a u-shaped function. So we've done that, but we haven't done the cubics or the quartics or the quintics and stuff like that. And that's fine. But for today, we're just going to focus on identification of those functions, like knowing when they are. Cubic functions, quartic functions, quadratics. We're going to focus on how we can tell how many times one of those functions is going to change direction, right? So if a function like is going down and then up, we say it changes direction once because it was going down, then it changed to going up. We're going to talk about its endpoint behavior, so what happens on the left side and the right side of the graph. Not so much in between, we just want to know what happens at the endpoints. Okay, so we're going to discuss that and then we'll be done. But all of that has definitions, so it's going to be definition heavy. I will pause the video or give you guys time to catch up and stuff. I know I already gave you guys a bunch of time to do that right now before I started recording. But let's talk about the polynomials or the names of these polynomials. So you'll notice numbers 1 through 5, they all have A and then B and then some have C, D, and E, and F, right? Those are just constants, okay? Or I guess you could say coefficients. Those are the numbers in front of the variables in some of these cases, okay? So for number 1, A is a coefficient. Okay, for number 2, A and B are coefficients. Okay, numbers in front of the variables, right? For number 4, A, B, C, and D are coefficients. Okay, so anything that has a variable stuck to it, those are called coefficients. The other numbers that are just hanging out by itself, so for example, number 1, the letter B, that's just your constant. It's just a number, okay? So for number 1, B is a constant. For number 2, C is a constant. For number 3, D is a constant, okay, because there's no letter on there, all right? Now, it's all based on the powers. That's how we classify them. So if you look at number 1, the letter X, which I put in red to really highlight that part, X to the first power. We don't write the 1, right? But X to the first, we call it a linear function. But if the highest power is a 2, we're going to call it quadratic, right? So that's number 2. Number 3, the highest power is a 3. We call it cubic. If the highest power is a 4, we're going to call it quartic. And if the highest power is a 5, we'll call it quintic, okay? And there's a lot more, but this is as much as we're going to have to go, okay? So there will be questions like this on your homework, okay? It's almost as ridiculous as it seems, but they're going to ask you, and be careful, okay? Name the polynomial. Your job is to find the highest degree or the highest power. We're going to talk about degree in a bit. We're going to look for the highest power, and then based on that highest power, what do we call it? So what's the highest power on example 1, part A? A cubic. Well, it's a 3, right? So yeah, it's going to be called a cubic function. So I'm going to write cubic function. And that's all you have to do, nothing more than that. But notice it might be useful to have the definitions up on top so that you can classify them, right? In case you forget the name or something like that. What kind of function is part B? It's quartic, yeah, because the highest power is a 4, bless you. The highest power is a 4. Don't always look in the very front to see what the highest power is, because it doesn't mean that they have to write the expression with the highest power in the beginning. It can be in the back, it can be in the middle, okay? But our highest power is a 4, so this would be quartic, okay? So, again, there are questions like this on your homework. I think there's like 3 or 4 of them like that. So very easy, okay? Very easy to do. You just got to know what the name is based on what you see, okay? And that's what all that writing was up on top, is a way for you to figure out how to classify these functions. So, I mean, would you agree simple? Right? Nothing too terrible? So, now, there's some more writing here, so I will pause it, okay? And then I'll get back to describing this stuff. All right, so we're back here. So the two main things you have to know for the next example is what is the degree and how do I find the maximum number of turns that a function can do? So the degree, it's the highest power in a polynomial. So we already mentioned that earlier, right? Like I would ask you what's the highest power so we can classify the function. So the degree is basically the highest power. So when I ask you what's the degree, you're going to look for the highest power, and that's the number you're going to tell me. Okay? So degree, the highest power in a polynomial. And then they're going to ask you how many turns does these function or does the graph of this function have? So how many times is it going like up and down, etc. The way you figure that out is you figure out the degree and you subtract 1. Okay? So the degree minus 1. That's the maximum number of turns that a polynomial can have, the maximum number of changes in direction. Okay? So, example 2 says, name the maximum number of turns of the polynomial. And for part A, they give us f of x equals to negative 3x to the 6th minus 6x to the 4th minus 12x plus 4. What's my degree for this problem? Just out of curiosity, let's write it down. What's the degree? 6, right? So the maximum number of turns, I'm going to put right here, max turns, is going to be 6 minus 1, so that's 5. Okay? So just get your degree, subtract 1, and that's it. Not hard. Like I said, I don't think the work is difficult. I just think the fact that you have to know so many definitions is what makes it difficult. Okay? Because then you got to be like, okay, what was the degree again? Let me look back and check. What about for part B? What's my degree? All right, so we got a 5. So the maximum number of turns is how many? It's 4. Yep. Max number of turns is going to be 5 minus 1. So that's 4. So again, I think it's pretty simple. I just got to know my definitions. I got to know what it is that they're asking me so that I can do the work they want me to do. Okay? Now, the hardest part of this lesson is coming up. Okay? Still not difficult, but the definition is pretty complicated. Okay? But once you get it, it's not that big a deal. So again, I'm going to pause this thing so that you guys can have some time to write this down. So we'll start off with this one right here. All right, so now for the trickiest part of the lesson. Okay, not saying it's difficult, but it is a little bit more involved. So we're going to talk about the endpoint behavior of a polynomial function. So there's going to be times where they're going to give you an equation and they're going to say, okay, tell me what happens at the endpoints, like towards the left and towards the right. What is this graph doing? Is it rising or is it falling? Okay, so by definition, you're supposed to be given a polynomial. So that's what that means. Let f of x equal to ax to the n plus b times x to the n minus 1, etc. They're just saying, look, you got a polynomial. Okay? So let f of x be this polynomial. Now, an important thing for us to note about these polynomials is this, okay? The leading coefficient is the number in front of the variable with the highest degree. So once you find your highest degree, okay, once you know your degree, look in front of the variable. That number is called your leading coefficient, okay? So I'll write it down for us right now. This is called your leading coefficient. All right, so a coefficient is just a number in front of a variable, so I mean, not a big deal. But leading coefficient is called that because it's the number in front of the highest power variable. Okay? So it's kind of like getting a promotion of a job, right? Like you're not just a worker, you're like the manager, right? So that's kind of what the leading coefficient is. So it says if n is even, so in other words, if your polynomial function has a power of 2 as a degree, or a 4, a 6, an 8, a 10, a 12, an even degree, if n is even, then look at your leading coefficient. If your leading coefficient is positive, then the answer you're going to write for me is that it rises to the left and it rises to the right. If your leading coefficient is negative, you're going to tell me that it falls to the left and it falls to the right. I mentioned to you guys a little earlier, while the video wasn't recording, that if anything, from this, take the fact that if your degree is even, that they rise or fall. Both sides will either rise or fall. So it's either going to be rises left and rises right, or it's going to be falls left and it falls right. Okay? They both endpoints do the exact same thing when your degree is even. Okay? Now, if your degree is odd, some other stuff can happen. All right, so if n is odd, we have a different situation. Okay, the endpoints, by the way, if you're wondering, what the heck is he talking about endpoints? I'm talking about this stuff right here, guys. The endpoints, okay, the arrowheads. Which way are they going, right? So these are endpoints right there. That's the behavior of those. Okay, so if n is odd, then and if a is positive, then it's going to fall to the left and rise to the right. Again, it doesn't tell you what the middle does. Who knows what the middle is going to do? Okay, but I can tell you for a fact that if your degree is odd and a is positive, your leading coefficient is positive, then it's going to fall to the left, it's going to rise to the right. Okay, and if a is negative, it's going to rise to the left and fall to the right. Okay, so that's going to be the behavior of it. So let's go ahead and do these. I think this is our last example, and then we're done. Like I said, the most math you guys are going to have to do is subtract by 1. So definitely, I would say the easiest mathematical lesson we've done in terms of computations. Okay, just minus a 1 every once in a while. That might be it. All right. So for example number 3, it says describe the end behavior. Okay, and part A, they give me f of x equals to negative 2x cubed plus 6x squared minus 4x plus 5. What's the degree on this one for part A? It's 3, so it's odd, right? N is odd. I'm going to write this down right here to the side. I normally don't do it, but I want to make sure you guys kind of see it. So N is odd. What about A? Is A positive or negative? It is negative. It's a minus 2. So look at the notes that we just took. What happens when N is odd and A is negative? So look at the list. If n is odd and a is negative, what does it do to the left? It rises. So I'm going to put rises to the left. And what happens to the right? It falls. Falls to the right. So look at the section where it says n is odd, a is negative. It rises to the left, it falls to the right. All right, what's my degree on part B? It's 4, so n is even. And a is what? Positive. So if n is even and a is positive, what does it do to the left? It rises. And what does it do to the right? It rises, because even ones do the same thing on both, right? So it rises to the left and it rises to the right. And this is all you guys have to know how to do for today's homework. Okay? Classifying. That's basically what we're doing today. It's just classification. Classify this function based on what you see. Okay? Tell me what it's doing based on what you see. All right? So that's it for today's lesson, and I'll give you guys your homework in a bit.